What's up? This is your algorithm video coming at ya. Okay, so you gotta go to your performance task survival guide. As you can see, I have my survival guide open. And go to the algorithms on the Create PT 20 minutes. Hopefully this video is not 20 minutes, but anyways. Alright, so we're going to talk about what is a good algorithm, and we're going to look at some examples of good ones and bad ones, so you can know what you're doing. So an algorithm are a precise sequence of instructions for processes that can be executed by a computer and are implemented using programming languages. They make use of sequencing, selection, or iteration. People write programs to execute algorithms. Your algorithm must include two or more algorithms that work in combination to achieve some desired result. Finally, it must integrate mathematical or logical concepts. And we'll talk about those two items. Okay? What does it mean? So they're chunks of code that make a task. Okay, so we use these as functions usually. So to make sure your algorithm is a little complex and that you demonstrate your programming abilities, the College Board asks for a few requirements. Okay. So I would say before you decide what you want to make, I would make sure what you think about will be able to implement one of these algorithms. That would be kind of like a big goal. Okay, so I think this is the most important part. So something you wrote. The entirety of your code that you submit must be something you wrote, not something someone else wrote. Mathematical or logical concepts. So mathematical means it has some sort of computation like addition, subtraction, multiplication, division, or percentage. Something like that. Logical means you need to have some sort of probably like a loop or a comparison. So these are and or statements, not equal to, greater than, less than, greater than, equal to, less than. So usually they're in our if statements or loops. Okay, so you need both those things. So you got to kind of think like, what have I done? What can I use? Mathematical and logical. Okay, a parent and two children. Your selected algorithm must have two included algorithms that work in combination to achieve a result. The best way to think about this is that you have a parent algorithm, so like a big boy, that requires two or more components that can stand on its own as independent ones. So this would be like writing a function, and then inside that function it has two little functions. So that's kind of like how we would talk about it. Okay, you should not submit three separate algorithms. Instead, you should find one large task in your program, so one large function, that can be divided into two or more subtasks. Okay, for example, a larger task might be taking the user login screen, subtasks might check their information, and then set the appropriate screen. Okay? Talking about your algorithm, it's recommended that you place your selected algorithm and included algorithms in separate functions. Okay, this will make it easier for you to talk about them. So basically, using separate functions. All right, let's go ahead and see if it counts. Does it count? Okay, so here's the criteria. This is straight from the College Board of how they get points. So the selected code segment implements an algorithm that includes two or more algorithms, like we said, has mathematical or logical, and then there's an explanation part that's in the written part. Okay? And so we can read through this, but let's just jump in. Let's go ahead and start. So you're the reader. We're going to determine if they get the point. Assume each algorithm snippet below was submitted as a part of a written response. Okay? So yes or no, should it be given a point or not? Okay, so we'll look at these first two. Okay, so the first one, on event. So on the event, I'm going to click a button, and then it should set my background to the color blue, it looks like. So if I click button 1, I get the back color blue, and then on event, if I click the ID button, it looks like right here, then it's going to set my color to red. So there's two on events. Is this a good showing of an algorithm? Well, I definitely don't see any logical, and I don't see any mathematical expressions. Do I really see functions using other functions? Probably not. I'm going to go with most likely no. We'll take a look though. Let's look at the next one. On event. So if I click button 1, it's going to set the background to be blue, and I'm going to set the property of the font size a random number between 20 and 40 and play a sound. So a lot more is going on in this one event. Okay, let's see. Have we created an algorithm in any of these? I don't know. Let's look at our answers. Boom, here we are. So, first one. No! This is not, no way. Take your pick of the criteria. This doesn't meet any of it. No math, no logic. It's a single instruction. There's no interrelationship. Meaning, these two events have nothing to do with each other. So, remember, there's supposed to be a parent function that has two little baby functions inside of it, right? So this example does not demonstrate the basics of the algorithm, sequencing, selection, or iteration. Okay, next one. No, this alone does not have two subcomponents that combine together to form a single, more complex algorithm. It is two separate, but they don't combine. The use of random numbers likely would not meet the criteria for a mathematical concept. So random number does use numbers, but it doesn't use any of the plus, multiplying, adding, dividing. So, boom, no thank you. All right, let's move back and do the next one. Okay? All right, this one looks a little bit more substantial. Example 3. All right, so we have a function called manage the login. All right, so if the login status is equal to logged in, then show the home screen. Otherwise, hit reset login. Okay, so we have an if statement using an equals, so that's a logical statement. Good. Okay, and then, so this is the main function, and it uses a function called show home screen, which we define as setting the screen to home and the ID to text. So we have this major function uses the show screen function, and then we also have a reset function. So we do have two baby functions inside of it. So does this earn the point though? Pause the video and think to yourself. Nope. It is so close to earning the point. Okay? So it does have a main algorithm, manage login, that includes two separate algorithms, show home screen and reset login. But neither of the included algorithms include a mathematical or logical concept, so this would not earn a point. Okay? So the included algorithms, a mathematical or logical, I would say it does have a logical, but it doesn't have a mathematical one. So you need a mathematical one. So no. Logical, it does have an if-then statement where it does use the equals. So definitely does not have a mathematical one. So no point, but it does get the function right on that one. Alright, moving on. Let's go with number 4. It's a good one. It's a long one, so it's like gotta be right, correct? Okay, so we have a function called increase score, which does what? It makes a score to score plus 1, and then it checks to see if the end game, so there's another function, if end game, then it's going to set the text to the time plus total time in seconds, otherwise it'll update the screen. Okay, so we have a function, main function, increase score. If in that function it updates screen and it checks, so we have two separate functions. So notice main function, and these are the baby functions that are inside the main function, or the parent function with the two children functions. Okay, I see a plus sign there, so I'm thinking maybe there's a mathematical, but let's keep going. Function update screen, so this is a basic one, random numbers, not mathematical, but it does set some score, make some sound. Fine. Check in game. Ooh, we have equal signs, and we have dividing by 1,000, so we do have a variable here where, the OR statement right there. So we have a logical statement here, and we have a mathematical statement. Dividing by 1,000, mathematical. I would say plus 1 up here is mathematical. The OR statement right here, if these two things meet, then we get to say the game ends. So I'm going to go with yes. Let's see what's the right answer. Yes, it does. Okay, the main algorithm, increase score, which is this one up here, has two sub-algorithms, update screen and check in game. Awesome. The latter has both mathematical and logical, so this one has mathematical and logical. The main algorithm also has logical components, so right here. And it relies on the result of the sub-algorithms to function properly. That's kind of a key one right there. So the main algorithm requires these two in order to function. It's worth noting this code probably functions weirdly, but can get credit. It only gets credit if the written response actually describes it, so we do have to describe it well. Also, this code is broken into functions, but doesn't have to be. Pulling the included sub-algorithms into function makes them much easier to identify separate from the selected algorithm. See next example for one that doesn't break into functions. I highly recommend you do what they did. Break them into two separate functions. Okay? In this case, you have a main function with two separate functions built in. Way smarter, way easier. We can also use this for abstraction later. Okay. All right. Moving on. Next one. I think this is our last one, right? Number 5 is the last one. Yeah. Okay. So we have a while loop. Fun. So while loop is done equal to false. Okay. So the variable n is going to be the prompt number. So enter your secret number. So if n is 97, then true. Console log, you did it. Begin countdown. So here we have a loop right here. So that's gonna a loop. So we have a while loop, which is the whole thing. That's kind of confusing, but that's the whole thing. And then we have an if then statement that starts here. If n equals 97, you do all this, which loops something else. It goes to you've guessed correctly. And then it has an if-then statement within that. Okay, so we see a lot of logical statements here. Do we see mathematical statements? Do we see other functions within functions? Well, it's not written with functions like example 4 is. So let's take a look. In a book, reading rainbow. Okay, yes. This one is tough, and I wouldn't recommend picking one like this. I'd pick one like example number 4. But this does work because you need to carefully, so let's look at it. The selected algorithm is the entirety of this code, line 1 through 19. Okay, so that's one thing. It repeatedly prompts the user to guess a number. If the user is correct, then the sub-algorithm, lines 4 through 10, boom, boom, runs and rewards the user with a message and a countdown from 97. If the user is incorrect, then sub-algorithm to 11 through 18 runs to give the user a hint on how to make their next guess based on the previous one. Both include algorithms use logical concept, as does the selected algorithm. So it's like if you get 97, you did it. If you didn't, then it's going to tell you to guess higher or lower depending upon what number you put in. This is an example of a segment of code that fits the requirement without breaking included algorithms into separate functions. We think that breaking into separate name function will make it easier, but it should be clear this is not a requirement, only a recommendation. I still, okay, sorry about that. My son is playing in the car right outside the garage and set the car alarm off, so, okay, let's get back to it. So, anyways, this one does work. I think I was talking about mathematical statement here. And so, mathematical-wise, we are here using within the loop. So I think they're counting this part right here for the mathematical component. So I think that's what it is. I don't really like this one as a great example. I would highly recommend doing one more like this for the algorithm. Okay, so that's what you're looking for when you're creating algorithms. So think about a program that you could run that would have been built in. So I'd recommend going back to your previous projects, looking at the code that you've written and see if you can find one that would work like that, and then you can probably make a program that's very similar to it, maybe make it a little bit more interesting or something like that. Okay? Alright, boom, 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 algorithm video out.